Greetings, mathematicians. In this video, we're going to be starting with the learning target related to simplifying square roots. Before we begin, we'll start with a quick warm-up, reviewing finding the prime factorization. So I'm going to have you start by pausing the video and trying these two problems, finding the prime factorization of these two numbers. So go ahead, pause the video, and then come back to check your answer. All right, now you might have approached this in different methods, but you may have started by saying, okay, I can break down 50 into 2 times 25, 2 is prime, and then I can break 25 down into 5 times 5. So the prime factorization of 50 is 2 times 5 times 5. That would be one way to approach it. So your work might look different, but your answer should either be 2 times 5 times 5, or you could rewrite that as 2 times 5 squared. Either of these would be appropriate solutions. And then same thing for your solution for 48. Depending on how you decided to break that down, you might not have used a factor tree like we did with the first one. You may have maybe done this in your head or aided with a calculator. Maybe you said, oh, well, this is 2 times 24. Don't write down the 24 because you know that the 24 can break down. 24 is 2 times 12. Don't write down the 12 because you know that that can break down. 12 is 2 times 6, and 6 is 2 times 3. You can leave your answer like that. That looks good. Or you could also rewrite it as 2 to the 4th times 3. So either of those would be appropriate. So moving on here, our essential question today is, how are we able to simplify square roots? And there are a couple of ways to do this. One method is going to be building on the skill that we just did in our warm-up. Another method might be to work with perfect squares. So let's also take a chance here. Let's pause the video again and let's have you work on listing out all the perfect squares from 1 to 100. Then come back and check your work. All right, so now that you've had a chance to try this, here is an example way that you could have done your work and then come up with your solution. So our solution, the list of the perfect squares from 1 to 100 is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. And the way that we obtain these is we start for counting at 1, then 2, then 3, etc. We square those numbers, so 1 squared, 2 squared, 3 squared, 4 squared, etc., until we get to 100. Now, where these will come in handy is that some people prefer, instead of finding prime factorizations to simplify square roots, some people choose to use these as their basis for their work. So you'll see where this is going in just a moment. Now moving on here, hopefully you recognize this notation for radicals. That's the symbol here around the 4, this radical symbol. Now technically this is not written, but this is a square root. So we don't always write this little 2 here. Sort of like how if you just see an x, that's the same thing as a 1x, 1 times x. Or sometimes if you see something like, if you would see also this x, this is like an x to the 1st power. We don't always write that one either. This 2 is the index, and we don't always write that index. If there's no index written, it means it's a 2. So these are all called square roots. There are things called cubed roots or 4th roots, etc. You can have any index you want. So this could be like a cubed root here. We're just not working with those at this moment. For now, all of these are going to be square roots. And when you see this, what you should be thinking to yourself whenever it's a square root, you should be saying what number times itself equals the value inside. So just as a quick refresher here, because you've probably seen this symbol before, when you look at this, you should say the square root of 4, and you should think to yourself what number times itself equals 4. And hopefully it comes to you pretty quickly that 2 times 2 equals 4. And 8 times 8 equals 64. And 10 times 10 equals 100. So it's basically just the inverse operation of what we did just a moment ago where we were squaring or multiplying the numbers by themselves. This is going in the opposite direction. So just a quick summary before we move on. All of those examples we just talked about were called square roots. In your mind, you're asking yourself, what number multiply it by itself gives me the number under the radical. That number is called the radicand, by the way. And again, it's the inverse operation of squaring a number. Next up here, we're getting into something that might be looking a little bit more abstract, but we're going to look at some examples coming up next here. And we're looking at some properties of radicals. So our goal when we go to simplify something, and we'll do this with the 8 here shortly, this square root of 8. We want to try to simplify these radicals. And the way we're going to do that, this 8 is really, in this case, our AB. And what we want to do is we want to try to break it down into some sort of product. And then break that into 2 separate radical problems multiplied together. But we want to be strategic about that. We want one of these 2 radicals, either the A or the B, it doesn't technically matter because multiplication is commutative. We want one of them to be a perfect square. And then we want the other one to be kind of the leftover factors that don't simplify. And then that's how we know that something is in simplest form. So what we're going to do is we're going to basically find the prime factorization of the number that's inside of the radical and break it down into a product. That's what your A times B is. So let's see what that looks like. All right, so for this first example, example 4, square root of 50, we're going to show a lot of work here, and then you can kind of maybe back off and show a little bit as you get more comfortable with this. But your first step would be to find the prime factorization of 50, kind of like we did in our warm-up today. So we're going to start by taking 50 and breaking it down as much as we could. So for example, 50 could be written as 2 times 25, and then 25 could be written as 5 times 5. Now, because this is a square root, we're going to be looking for things that come in groups of 2. That's all we're working with right now is square roots, but just as a note for the future, if you were working for things like cubed roots, you'd be looking for groups of 3. If you were looking for fourth roots, you'd be looking for groups of 4. So that's why we're looking for groups of 2 here. Now, next thing we're going to do is we're going to use our product property that we just wrote down previously, and we're going to break this up into 2 different radicals. Breaking it up so that the ones that are in groups of 2, those are together, and the ones that are not groups of 2, those are together in different sets of radicals. Now, the ones that don't have groups of 2, they can't be simplified. They're just going to stay the same. This is just going to remain a root 2. And remember, you don't really need to write the index of a 2 there. I'm going to drop that at this point. Over here, remember that multiplying by itself, 5 times 5, which is 25, that's the inverse of taking a square root. So those 2 operations are going to undo each other. So 5 times 5 is 25, and then you take the square root of 25 and you get back to 5. So this is just 5. So now we have the square root of 2 times 5. Now, in terms of convention, we typically write the whole number part first, and then the radical part second. It's sort of like, just kind of a side note here, if you were to write x times 5, you would rewrite that as 5x. Same thing here. We would typically write the whole number coefficient type part first in front of the x. You do the same thing here. You'd write the 5 in front of the root 2. Now if we move on, we do the same thing here with the root 48. Square root of 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So there's our prime factorization. Next, we're looking for things that come in groups of 2. Anything that is a group of 2 is going to be written kind of separate like this. And then anything that's left over is left over at the end. Square root of 2 times 2 is just 2. Square root of 2 times 2 is just 2. And square root of 3 remains square root of 3. 2 times 2 is 4. And 4 times root 3 is 4 root 3. Now again, similar here, we don't always write the little dot in between multiplication. You might just write them next to each other. And remember, when you have two things next to each other, similar to what we had over here when we had 5x, that means 5 times x. So 4 root 3 means 4 times root 3. All right, and then this last example here, this one was a little different than our warm-up. We didn't already find the prime factorization of 125 yet, but 125 is 5 times 25, and 25 is 5 times 5. Looking for groups of 2. Things that are in groups of 2 go in their own square root. Things that are not in groups of 2 are left over. Square root of 5 times 5 is 5. So our answer is 5 root 5. All right, we're going to stop here for now, and we'll look for you in the next video.